Hello, good day. Today is day 3 of the AI Innovation 2022 2023, organized by Data Scientist Network, and is brought to you by Hamplus Hub. Hamplus Hub is located in Delta State, Nigeria. Okay, today we'll be looking at supervised learning, and as you can see on screen, we have introduction to regression analysis. So the first thing we have to do, we need to import the required libraries. And the libraries we'll be using in this case, we have pandas, we have numpy. Pandas and numpy. Numpy is for numerical computing, while pandas is also built on numpy, or is an advanced form of numpy, which is for statistical computing and not just for numerical. So we have some visualization packages here, which is Matplotlib and Seaborn, that are used for visualization. A Seaborn visualization tends to be more beautiful than Matplotlib visualization. sklearn is used for as the model building framework or library, and it contains a lot of algorithms, such for model building, some for splitting of the data sets, some for encoding, and some are to actually perform metrics. So for the model, we have both the linear model, we have the ensemble model, we have the tree models. Okay, so what we have to do, we have to ensure that after we've imported the libraries, we load the data set. We have to load the data set, and in this case, that is the part of the data set. So we're using dataset.xlxl. It's an Excel file saved in Excel format. So we'll use pv dot read underscore Excel. Remember, we imported pandas as pv. So we loaded the dataset and stored it inside a variable called df. So we investigated the variable by seeing the head of the variable. Now, when we use head, df.head, without any number in the parentheses, it gives us the first 5 observations or the first 5 rows in that data frame. Then, if we should specify a number in it, like 3 for instance, it gives us the first 3, because in this situation we have actually told the function or the method that we need the first 3. So whenever you use head, it gives you the first, then the opposite of it, to get the last, you use tail. So if I want to get the last 5 by default, I'll use df.tail, and it will give me the last 5 observations. If I specify a value inside the parentheses, just as in the case of head, it gives me that number of observation. Note, it must not be that I specify the value less than 5 or equal to 5. I can specify df.head 10. It's giving the first 10 observations. It will give me the first 10 observations. Okay, so and you can see from the observation, you have the header, the location, the headers of the data frame will always be indicated. Here you have location, you have the maker, you have the model, you have the year it was made, the color, you have the amount, you have the type, and you have the distance. So this data set actually is about fairly used cars. Fairly used cars. So the location where the car is presently is in Nigeria. It tells you Abuja. For example, the first observation tells you that it's in Abuja, and the maker that made the car is made by Mercedes-Benz, by Mercedes. Then the model of the Mercedes Benz, because every car has a model. So the model is GLA 250. Then the year it was made. Every model have different year. You can have a model GLA 250 made in 2015. You can have another one made in 2018. So it just differs. So then we have the color, we have the amount. Note that the amount is a million. So what you're seeing there as 14.50, when you multiply it in millions, it will give you 14,500,000. So that is for the car. Then you have the type of the car, and also you can observe that, oh, okay, you mean the heads? Yeah, the first thing I have to do, I have to import my libraries. If the libraries are not imported, there is no way I can use the functions or the methods in the libraries. So then the last column, or what we call the last feature in the data set, is actually the distance covered, as the distance the car has been used. So proceeding, we use the .info to get information about the data frame. So .info will tell you things about the class of that object, that is df.info. It tells you that, oh, the class is panda.core.frame.dataframe. That is the data frame object. Okay, then it tells you the range, which is the number of observations, It tells you that. Then also you find out that it tells you the number of columns that you have in the data frame. Also, you can find out that it gives you all the column headers. Then it tells you the number of not null in each of the column. Also, it tells you the data type of each of the column, like the column by column data types. So from this, you can see that we have how many objects. The summary is giving. We have 5 objects, 1 integer, and 2 floats. Now, an object in data frame is seen as anything that have a string. So let me take some water. Okay, thank you. So anything that have a string is of the data type objects. So it can be a number, but it has a string. So that is a numeric object. So in such a situation, you have to typecast it. You change it from being a number, from being an object, to either a float or an integer. A float is the data type that has the presence of the decimal point, while an integer does not have decimal points. Okay, you can also observe you can observe that df.describe, what does it give us? It gives us the descriptive statistics. It gives us the descriptive statistics of the data frame. What I mean by descriptive statistics is simply the count, the mean, the media, the mean, the count, the standard deviation, the marks, and the percentile, 25th percentile, 50th percentile, and 75th percentile. That's what it will give you. And when you use df.describe, it gives you just the descriptive statistics of the numeric data types, either floats or integer. But if it is not a numeric data type, it will not produce, except you use in the parentheses include equals to the type of, that is the data type. So if you want the objects to be included to do a descriptive statistics on the object, you use df.describe in bracket, in parentheses, include equal to objects. Include equal to objects. So then when we are done with this, the next thing to be done is ensure that you clean your data type. You clean your data frame. So what does it mean to clean the data frame? It simply means taking away the null values. Taking away the null values. That's one. You take away the null values. Secondly, in cleaning the data frame, you ensure that the inappropriate types are engineered on, or what you can call data wrangling. You ensure that the inappropriate types are engineered on. So if a particular column ought to be, if a particular column ought to be of the type floats, but I'm seeing it as a string, then that's an object. I have to ensure that I change it to integer. Also, if a type is of, if an observation, sorry, if a column as a feature is of the type, string object, and it ought to be date time, I have to convert it to date time so that our model won't have issues. Okay, so in cleaning the data set, or we call it the data frame, I'll take away the null, and from observation you can appropriately see that the null analysis in this data shows that only the distance have 1555 null values. 1555 null values. In the case of null, there are events that can be done. We can choose to either take the values away, or we can choose to fill it. Now, in taking the values away, we must ensure that the number is not as much that it will affect the data set. If the number is so large and we take them away, it will minimize the data set, which at the long run will affect the model we are trying to build. So in this case, 1555 is a whole large number, and we are not going to take it away. So we are going to fill it. And in filling, we have some strategy like the forward fill, like using the mean value to fill, and using the mode to fill. So in this case, we use the mean value to fill to fill the null values that are in the feature distance Okay, so after filling, we'll look for the null values again, and we'll find out that there are no null values. Okay, so good and fine. We just investigated all the data to see the types of data. Now we found out something, that in the location we have Abuja, and also there are some locations I want to change all the locations from Abuja to ABJ. So we just simply use dot replace. The replace method, we can use it to replace. Now when if we are replacing uh more than one value in a column, we can use the replace method in in a dictionary. We can use it in a dictionary. Okay, so after replacing, we just looking for the sum continuously, the sum of the null values, and we went straight to okay, we went straight to look at the data frame. Look at the data frame. I want to pick out the unique values. Then we'll find out that in the location there are some unique values, but I'm talking about the data type, that the model is so large. The unique values, they are so much. They are just so much. So we investigated, and in the process of model building, being that machine learning models don't accept strings, the strings have to be one hot encoded or label encoded to numerals, and if the values in that particular column are so much, it can lead to high cardinality. You can just see the this for this for the model, and find out that it's so large, so we just have to drop it because we need to avoid the cardinality. Then in this process, we did our one hot encoding. First and foremost, we change the categorical features, the categorical labels or attributes. We have to specify the data type to category and not just string, because they are actually categories. So specify them to category. Then after specifying them to category, we want to one hot encode it so that it will become numerals and not just string. So we did that, and you can see everything has been properly changed to integers. Please ensure that whenever you are building your model must not have, that the data you use to train your model, it must not have strings. You can use one hot encoding, or you can use the label encoder to transform the strings to integers, from the strings to integers. So that's what we did here. Then in our outputs 18, cell 18, you can see everything again. So we have to drop those features that are not numeric. We have to drop them. We have to drop the feature. We have to drop location. We have to drop maker. We have to drop year. We have to drop color. We have to drop type. Or we have to drop type, because some of the types are Nigeria use, some of the types are foreign use. We have to drop them away. This is a regression problem, and a regression problem is one that allows you to predict a continuous value. So you are not predicting a categorical value, a discrete value. You are predicting a continuous value, because we want to predict the price of the car. And if I can remember vividly, this is to predict the price of Nigerian used vehicles. So this thing on one hot and cozy, this just show that we dropped those ones we don't need. And here comes the process of the model building. In building your machine learning model, you have to take notes that after your data has been transformed from string to numerals, you have to ensure that you first perform the vertical split, which is you get your input variables and you also get your targets. The target is simply what you want to predict. In this case, our target is price, because we want to predict the price, or our target is amount, sorry, because we want to predict the price or the cost or the amount of Nigerian used vehicles. Nigeria used vehicles. So if we are to predict maybe the model or something else, then that will be the target. That will be the target. Why the input variable are the features that you intend using to predict the targets. And these features, for experts and for professionals, though this was not done here, because this is just a basic and elementary training. For experts, before you select your features, you have to go through feature selection process. And feature selection process, you can use what we call the correlation. You can use correlation to get your features. In using correlation, you ensure that you pick features that are not correlated to the targets, that are not correlated to the target. Let's say, for instance, I have price and I have amount. Then price is not represented in standard form, but amount is represented in the standard form. I have to drop price because price is correlated to amount. So any feature that is correlated, highly correlated, you drop them off. You drop them, because this feature means the same thing as this other feature. So you have to drop out those features. So after choosing your input and output variable, then the next observation is you have to specify the splitting, because after you split vertically, the next splitting is done horizontally. It's done horizontally, which means you have to split into train and test. The test is to enable you use data to test your model after it has been built. So in splitting it, we use the train test splits. The train test split. If you understand Python very well, you know what we call packing and unpacking. Packing and unpacking, I think that is it. To unpack and to pack. So using train test splits, X, Y, the input and output. X is the input, is already represented as capital X. Y is the output, or what we call the target. And the third argument to specify in the threaded split method or function is to specify the size. Okay, note that it is also good that you specify random. Random equals 1. Random can be anything. For the essence of specifying random, giving it a value that is not 0, because by default, random is 0. And when random is 0, anytime that particular split is run, it will regenerate new sets of sub-data frame. I develop new sets of observation in X string, new sets of observation in X text. That's what it will do. So to avoid that changes anytime you run this particular cell, you must ensure that you set random to a number greater than 0. Any number greater than 0. Here you can see the test size is equal 0.3. Test size is equal to 0.3, which is the test size is 30, which is 30%, which is 30%. So you are just telling the algorithm that give me 30%, set it aside 30% of the train of the X and 30%. Excuse me, and 30% of the Y, that is the target. You set it and put it in X test and Y test. Then the remaining 70%, which is the train size, you set it into X train and Y train. So after splitting, we need to build our model. First model we use here is logistic regression. We're using logistic regression. In this logistic regression, for linear model in sklearn, we have to import logistic regression. After importing logistic regression, we have to ensure that we create an object which is a blueprint of what we just imported, logistic regression. Let's simply say we put the logistic regression in a variable. Now you can observe that there are nothing specified in the parentheses of logistic regression. This automatically enables the model to load the default values, the default parameters, or arguments, to load them, to use it in that variable. So after initializing the model, the first thing is to import the algorithm. The second is to initialize the model. Then the third is to fit the model, fit the X and Y into the model. Now let me explain this fixing. Fixing is like, okay, use this X and Y to learn this particular thing. After learning, you take the Y away, you give it X and say predict what, tell me what you've learned and show me, tell me what will be the outcome in the Y subset. So after you've done that, next you have to ensure that you you have to ensure that you make prediction. You make prediction. And to make prediction, you simply make use of the variable dot predict. You now make use of the predict class. Make use of the predict class, and you are supplying what? The X test. That is, this is what I want to use to test. I will supply X test, then you give me Y test. That's for prediction. So by default, we'll say, okay, let's look at Y test. We saw Y test. Then let's look at the prediction. You can see that the model is not doing so well because the first prediction have 18.25, but the real value is 6.5. But the second prediction, it predicted for 41.26, and the real value is 40. The third prediction, it predicted 41, and the real value is 8. So it keeps on going that way to predict. Now, this model can be hyper-tuned to give us the best and optimal performance. So, but in this class, we are not hyper-tuning the model. We're not hyper-tuning the model. We are just showing the basic approach to build a model. The basic approach to build a model. So we have to evaluate your model. After the model has been built and tested, you now evaluate it. You now say, okay, I want to see the score. In the case of classification model, you talk about the accuracy, you talk about the precision, you talk about the Evans score, you talk about the recall. But in a regression problem, you talk about the mean absolute error, you talk about the mean absolute error, you talk about the mean square error, and similar metrics. So these metrics for evaluation are gotten from the metrics class in sklearn. So from the metric class in sklearn, you just import the method mean absolute error, and we use that to calculate our mean absolute error. And it can be seen here that the model have a mean absolute error of 7.97, have mean absolute error of 7.97. So we can build other models, but we've just seen the basic way to build our model. So we have to ensure that in building the model, these are the steps we must take. First, we have to fetch the data. We have to clean the data that has been fetched. Fetching of the data can be downloading the data. Fetching of the data can be, okay, you get it from a source originally. Maybe you are recording it live from an experiment in a feed, but after the data has been gotten, you have to clean up the data. You have to clean up the data. And after cleaning, the cleaning of the data entails things like removing the null values, ensuring that they are in their proper types, data types. Then also you remove duplicates. You can remove duplicates. All these are processes of cleaning the data type. Then also you look for those entries that are inappropriate. For example, you recording the gender of participants in a survey. Some are likely to use letter M for male. Some are likely to use male, capital M. Some are likely to use male, all lowercase. Some are likely to use male, all uppercase. So in a situation like this, you have to unify all the different entries for the different values for the gender male. You have to uniform it and ensure that it is in one form. The essence of doing that, it is in one type. The essence of doing that is to avoid seeing these different values that have been entered as different classes. If you do not unify them, it sees them as different classes. Okay, after cleaning the data, you have to prepare the data. You have to prepare the data. In preparing the data, you have to perform some EDA, elementary data exploratory data analysis. You perform that, then you get your x and y variables. After that, you split the x and y variables, you split them. Then after splitting them, you go to the next stage of model building. You ensure that you build the model. After building the model, you test the model. After testing, you evaluate the model. If the model is okay, then you have to deploy the model. You have to deploy the model. Ensure after deploying the model, ensure that you monitor the model, you collect data and evaluate the model. Even after deploying the model, you ensure that the model is monitored, that it is working well, and you use the model to collect more data, and also you can have it that as it collects data, it retrains itself to learn better. So these are the stages you've seen in the cycle for machine for building your model. You have to pass through this circuit. So once more, briefly I'll show you the stages one has to go through to do this. First step, you import your required library. Second step, you load your data. The third step is you clean your data. After the data has been loaded, you have to clean it. You have to clean the data. Then after cleaning the data, you have another step to perform, which you have another step to perform, which is splitting the data. After you clean the data, you split the data, also we call data segmentation. So you have to split the data. After splitting the data, you train your data. Please note the steps. You train your data. After training your data, then you can make prediction to see how well the data is performing. After making your prediction, you evaluate your model. And you ensure that it is working the way you want it to work. It's working the way you want it to work. So after evaluating the model, you can decide to use other forms of machine learning algorithm to actually see a different accuracy or the different performance that the model will yield to. So that is end of the narrative. Do you have any question? Okay, the students in the hall don't have a question. Okay, yeah, you can ask. Yes, Yes, you must ensure that you split your data, you segment your data before building. Before building, this will enable you to also have data that has not been looked into by the model. That is, I refer to the test data. You have it and you'll be able to use it to perform what? To test your model. Test your model. Thereby, after testing, you now evaluate. It is very necessary that you evaluate your model. You evaluate your model. Then, after evaluating your model, you should proceed to deploy the model. You deploy the model. After deploying the model, then you ensure that the model is working well, is collecting data, and is re-evaluating or retraining itself continuously. Okay, so that sort of question, any other questions? This video is just the basis. It's just the basis. There are many other things that you see. So in the subsequent video, we'll bring those things on on the play so that you can see how to perform your feature selection, and also you'll be able to learn more on model building, to learn more on model building. Okay, so in the absence of any other question, yes, Python raw code can run very well when mixed appropriately with the NumPy or with the pandas or with anything. When you mix them appropriately, it will work very well. It will work very well. So the framework is not bigger than the programming language, but the framework is obedient to the programming language. It's obedient to the programming language. Just that it enables you to do things on an elevated mode without going through the rudimentaries of getting those things. It allows you to make use of petrol without you going to refine the petrol yourself. That's for instance. So framework is not bigger than the programming language. A framework must obey the programming language. Okay, I guess that answers your question. Okay, that's nice. Any other question before we call it a day? Yes, yes. You can actually perform this with your VS Code. Yeah, yes, in this work we did our programming with Notepad, Jupyter Notebook, Jupyter Notebook. But if you wish to access it in Visual Studio, you can also perform your model building, your data science, and everything in Visual Studio. You can perform that. Now, note, please, however, that this notebook format, which is .ipynb, can be uploaded in Google Colab. In Google Colab, that is an online repository where you have your your codes that you worked on. So, and you can also use it as online host for running your your codes, your data science code, your notebooks. So you can upload this notebook. I think you can upload any notebook that is in .ipynb format. You can upload it to Google Colab. You can upload it to Google Colab, and you can also work on Google Colab. You can work on Google Colab. But I prefer to work using the the Jupyter Notebook. That's what I prefer doing. I work with the Jupyter Notebook. So you can use any IDE if it supports that. You can use it very well. Yeah, we'll see build next class. We'll build a classification model, that is the machine learning tag that has to do with classification. So we've just seen the one that has to do with regression. So next class, we'll look at the one that have to do with what? With classification. Please note, logistic regression is different from linear regression. So from linear model, you import what? Linear regression, not you import linear regression, not the classifier, because you cannot use a classifier for a regression problem. It must be a classifier for classification problem and not a classifier for regression problem. I guess that answers your question. Okay. So with this, we'll call it a wrap for today. We'll call it a wrap for today. Tomorrow, we'll continue from where we stopped. We'll have to test this model. We'll have to see other algorithms if they perform well. If they perform well, you can actually see from the screen that the algorithm we use is logistic regression. Linear regression, not logistic regression, because logistic regression is for classification, but linear regression is for regression. So we made use of linear regression. So what next we'll use? We'll try support vector machine, which is SVR, support vector regressor. We'll also try random forest regressor, and we'll try naive Bayes, the regression algorithm. We'll try it out and see which of the algorithms perform better. That is the aim of using different algorithms. We just see which performs better. So that will be done tomorrow. We'll start from that tomorrow. So please have a nice day, and I believe it's a nice section we've had. So you can drop your comments. Please drop your comments, and you can also share the video. By sharing, you are caring for others that we want to see this video but don't know how to see it. They might be in your friend list. Just share the video and have a blessed time. Thank you.